Okay, it's working. Okay. So, hey guys, what's up? It's the Culture Detective here, investigating your favorite things, and today I'm going to film myself complete the 2019 Chemistry DSEs. I'm going to do both papers 1 and 2, because tomorrow I'm going to be doing my last chemistry exam of my life. So this is the second last chemistry exam of my life, and I'm going to do it within the time limit. Now, as you can see, uh, uh, right here it says 2 hour and 30 minutes, but actually I'm going to challenge myself and try to be even earlier than that. So there are actually 2 parts to this. I'm going to do a part first, which is the multiple choice questions, starting now. So my name, oops, alright, it is going to be uncut. It's going to be very boring, but I'm basically going to talk about my thoughts when I do these questions. Calculator here, let's go. Which of the following pairs of atomic numbers corresponds to the elements with similar chemical shoot? Do I have a... I don't have a... What the fuck? Okay. I need a periodic table real quick. There we go. There we go. I have a periodic table here. So, 414. Can you see this? You can barely see this. Great. Which following pairs of atomic elements with similar chemical properties? So 414, wrong. 818, wrong. 935, fluorine, bromine, yes. Okay, so we got the first one. C. The setup of the experiment is shown below. So the long one is positive, negative, positive, negative. And what can be observed after the circuit is closed for a period of time? If X is diluted H2SO4, the purple patch migrates towards P. Well, this is, okay, so, no, it cannot be purple. This side is positive, this side is negative, and dichromate is negative, so dichromate is the one that travels to Q, and dichromate is orange, so orange migrates towards Q, and it kinda has to be B because ethanol is pretty weak. So which of the following processes does not involve oxidation and reduction? Red wine turning sour, removing rust using white vinegar, combustion, removing nitrogen oxides and the catalytic converter of a car. Well, this is... I need to think about this. I think wine turning sour is actually a redox reaction because alcohol is formed, I guess. I'm going to say combustion. Wait a second. Is it combustion, though? I think it's combustion, yeah. Okay, if I'm wrong, this will be hilarious. Alright. Question 4. 25 centimeters cube of 0.051 molarity C4H4O4 can completely neutralize 22.18 centimeters cube of 0.115 molarity potassium hydroxide. What is the basicity of the acid C4H4O4? So, wow. So the number of moles of potassium hydroxide here is 0. You can see this, right? 0.115 times 22.18 over 1000. So this thing, and then the number of moles of this thing is 25, 1.275, and so this thing over 2.5507 times 10 to the power negative 3 is 0.5. What the frick? Shoot. Fuck. So this means we need 2 OH to get 1 H from here. So the basicity of this thing is 2 then. So it's B.
Yeah.
Okay, we have another calculation question. 25 cm cube of 0.5 molarity of lead 2 nitrate is mixed with sodium chloride. Insoluble lead 2 chloride is formed during mixing. What is the concentration of Cl minus chloride ions in the mixture? So, oh my god. So first of all, lead 2 nitrate. I feel like I need to balance this first. Okay, sodium chloride. I know this one. And then PbCl2, and then NaNO3. Except we need to make this a 2 in order to balance it, which means this must be a 2. That's why this Cl2 is a 2. So, okay, so we have a 25. So we have this many number of moles of lead 2 nitrate, and then we have this many number of moles of sodium chloride, and very clearly lead 2 nitrate is the limited reagent here. So 0.0125 moles, and the concentration of Cl2 formed is this thing times 2, because there are 2 Cl2 formed, 2 chloride ions per molecule. And then out of 25 plus 50, so it's 75 over 1000, 0.33 A. All right, pretty cool. Another wait, oh god, I need to calculate this again. Fuck you. All right, 2.53 grams of NaHCO3, sodium hydrogen carbonate. 2.53 over 23 plus 1 plus 12 plus 16 times 3 equals to 0.0301 mole. Until heated, was heated until no further changes, and 1.59 solid remained. Which of the following equations matches with the experimental result? What the frick? Solid remaining? I'm pretty sure solid hydroxide isn't made like this. Okay, so I guess I need to find the number of moles of the solid first. So if it's NaOH, then it's this thing. Okay, this is going to be tedious. So 1.59, so 0.03975 moles, which is different from that, so this is wrong. A is wrong already. And then we have this thing, 0.0279 moles. It's kind of wrong too as well, actually. Oh, it's not wrong. It's wrong actually, but because we have the mole ratio here, so this thing divided by 2 is not this, clearly. All right, and then we have Na2CO3, and 0.0187, could be this one, and then at the end we have plus 16, 0.0389. I think it is C, but I'm not sure. This is the best answers. I'm gonna circle it because I'm not really sure. Damn, it's already been 9 minutes. Fuck, I should go faster. The setup of the experiment is shown below. Alright, so this cracking. Broken unglazed porcelain is catalyst. Yes. Fractional distillation is performed in setup. Wrong, it's B. This is right because there are alkenes. No more gas collected. Yes, this is right. 39. Oh god, not another calculator. 39.2 of an oxide of rubidium contains this thing of it's not that bad. It's not that bad. Shoot. How do I I know a way. I'm gonna do it for every single, wait a sec. Okay, no. I'm gonna do this. 28.5 over 39.2 is a 72.7%, and then now I'm gonna do it one by one. Amazing, okay? Amazing. So 85.5. Nope, not 727. Nope. Okay. Oh, shoot. Oh, it's B. It has to be B. Come on. It has. Yep, it's B. It's B. It is given that. Oh, not one of these. Not one of these. All right. So propane, C3H8. When it combusts, it forms 3CO2 plus 4H2O. Formation of water like this, and then formation of propane like this. So the combustion of propane is this, negative 2,222, and then this thing is this thing times 4, and then the formation of carbon dioxide is negative 394 times 3. So we gotta find this. So which means, okay, I know how to do this. And then minus negative 104 C. All right. Can you see what I'm doing? Can you see what I'm doing? All right. This is an awkward position because I don't have a professional camera because I'm dumb. A part of the structure of a polymer is shown below. Okay. Which of the following can be a monomer of this polymer? I think this is it. So I think it's C. Yeah, it's C. Duh. Easy. Consider the following electrolytic cell. Oh, I hate this. This, and then boom, 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 boom. All right. What would happen during electrolysis? Oh my god. All right. So this is negative. This is positive. Huh? So, oxygen forms around A. Maybe, because the OH, the hydroxide ions, okay, so maybe A. B, chlorine forms around B. Wrong, because this is negative. Hydrogen forms around C. Wrong. Iron 2 forms at around D. See, this is negative. If it's, oh, no, wait. If it's negative, it can, oh, if it's oxidation, it's either A or D. I'm going to go with A, but it may be D. So I'm going to say or D, but my choice is A. So even if I'm wrong, even if the answer is D, I'm going to cross it because my ultimate answer is A, but I've considered D. Okay, so which of the following statements concerning the fuel cell below that can form water is incorrect? It's a primary cell, I don't know. Nickel also acts as a catalyst. Maybe. X can be obtained from the fractional distillation of air, which is water, which is oxygen, I think. The equation for the change at electrode B is oh shoot. I think it's A. Because you can recharge it. Right. Alright. Which of the following combinations is correct? OF2 is linear. I don't think so. CS2 is V-shaped. I don't know. And Cl3 is trigonal planar. Shoot. Okay, I have the NCl3, yes. No, wait, no, wrong. Trigonal pyramidal PF3, yes. Yes, it's D. It's gotta be D. Consider the following reaction. Which of the following statements are correct? The oxidation number of chromium decreases. Oh my god. Okay. Let's calculate it then. 0 minus negative 2 times 7 minus 1. 12? Oh wait. 6. And then this thing minus negative 3 over 3. So yes. This thing decreases. Only covalent bonds are broken and formed. That is wrong. Ammonium dichromate is not. So this is wrong. Green solid turns to orange solid. Nope. Maybe? Wait a I'm gonna go with A. Oh, definitely wrong, because it's originally orange. Alright, which of the following methods can slow down the corrosion of iron-made object connected to a piece of lead? Wrong. Because lead is not as reactive. Right? Yep. Plate a layer, yep. Connected to it, yep. Alright, D. Which of the following chemicals can be used to distinguish concentrated hydrochloric acid from oh shit. I don't think it's A. I don't think it's A. Silver nitrate solution? If silver nitrate solution react with hydrochloric acid, right? Then maybe the chloride ion turns to chlorine, and then we have the nitrate, which hopefully turns to this, which means this is oxidation, this is reduction. Yeah, I think 2 works. Copper metal. Nah. So it's B. Alright. We're only 17. Which of the following metal oxides can be reduced to a metal when heated with a carbon using a Bunsen burner? I need to turn on air conditioning. Alright. Only wait a second. Reduced to metal heated. Oh, nee, it's C. Alright, I know this. Are they both soluble in water? Nope, they're both not soluble in water. What? They have the same empirical formula? Most likely yes, given how they're doing this. They are in the same, wrong. Okay, B. Which of the following reactions does the underlying chemical act as a reducing agent? So it gets oxidized, I guess. This thing, what? Nope. This thing, does it get oxidized? Okay, this is tough. Okay, this is really tough. Reducing agent. So the other thing gets reduced. Okay. So yes, 3 is right. 3 is correct. Now either 1 is correct or 2 is correct. Is it? I think 1 is right because it got oxidized, but then not really, because both of them got oxidized. So there is no reduction. Is there reduction? I don't think there is reduction. So I think it's just 2 and 3 then. I'm not sure about this one. Aqueous calcium hydroxide can be used to yes. Yes. I think so, but I'm not sure. D. Alright. Diagram below shows a common glass apparatus. The first of all, acid in the grate. The bulb should be firmly held in the hand when being filled with acid. No, that's not necessary. What? I'm not sure actually. Exactly 20 can be transferred. No. What? It can be more. It can be more. 25 centimeter scoop. This apparatus should be first rinsed with distilled water, immediately followed by the. All of them are wrong. What the frick? Oh, yep. D. Which of the following are exothermic? Okay, 2 is exothermic. Yes. This is exothermic. Yes. This is not. So C. Which of the following statements concerning ethanol are correct? It is flammable. Yes. It is soluble in water. Yes. It is more. I don't know. I don't think so though. So I'm gonna go A. Okay, mercury has good electroconductivity at room temperature because mercury has delocalized electrons. I think yes. So both true, and it's an A. All right. Consider the following. Okay. This is annoying. A small amount of B is added at time T, and finally a new equilibrium is attained. And so it's either B or C because this is the concentration of C, but B is added. And if a little bit more B is added, then it's gonna drop down while this one yeah, it's C. I'm gonna go with C. Consider the following two reactions at a certain temperature, constant. Okay, so this is basically the reverse. 1 point. Yeah. Yeah, alright. The decomposition of Hi into H2, hydrogen and iodine, is reversible and a close. No, I fucking hate this. Lame. Okay, 0.13 over. Shoot. Okay, we need to square it because 2 moles of this, and then 0.6 this thing, and then 0.6 that thing. Alright, so 0.6 over 3, this thing squared, and then 0.1 over 3, this thing squared, 36. Let's go. The next, oh, we're only at 22 minutes-ish. What is the minimum volume, not another calculation question, gosh damn it, of 0.5 molarity sodium hydroxide needed to completely react with, okay, shoot. 400. Okay, so this is how many dm cube, and this is how many moles. 0.02. So 0.02. So we need 0.04 of this, which means 0.5 times this thing over 1000 equals 0.04. So 0.04 over 0.5, and then times 1000. It's 80. So yes, it's D. All right, I am moving numbers. The structure of limestone is shown below. It reacts with excess HCl to give Z as the major component. Which of the following is Z? So first of all, a Cl is going to stick here, and another Cl is going to stick here, I guess. So, B. Choose one combination from below in which X can make an addition polymer while Y can make a condensation polymer. So it's either A or B because we got a carbon-carbon double bond, and then it's yep, it's A because condensation involves taking water. Which of the following combinations are correct? This thing is what shoot. Okay, so 1, 2, 3, 4, 5. So it's already wrong because it's butanone. This is actually pentanone. Diamide 1, 2, 3, 4. Oh, maybe. Oh, nope. This is also wrong because this is an amine, not an amide. 1, 2, and then this is actually right. Ethyl methanoate, and then pentanal 1. Yeah, this is not. Wait, 1, 2, 3, 4, 5. Oh wait, it could. Nah, I think this should be pen 4 E now. Yes. All right. All right, let's continue. Which of the following combinations of the steps is correct? So, this thing is a carboxylic acid and also a ketone, and it sort of turns into X. So apparently you want to reduce it. If you want to reduce it, LiAlH4 is definitely the thing to go. So it's either A or C. Now for step 2, you want to turn, after you reduce this, you turn this COOH to just OH, and or COH, or actually CH2OH, duh. But then you need to turn this ketone into this thing. If you reduce this, this also turns to an OH. So you need to turn this OH into this carbon-carbon double bond. And in order to do that, you need... okay, so let's see. Concentrated sulfuric acid. Which of the following does not exhibit a characteristic of iron as a transitional metal? A. Wait, is... yeah, A. Because catalyst, multiple oxidation states, colors. Alright. Which of the following statements correct? H2O2 changes from 2 mole to 2 molarity to 1 molarity, while the other conditions remain unchanged. So the concentration of this is suddenly halved. The consumption of MnO2 will decrease. No. In fact, MnO2 shouldn't be consumed at all. So this makes 2 automatically correct. The volume of O2 formed will decrease. That is... Wait a second. Rate of formation will decrease, but doesn't mean the yield will decrease. I think so. Okay, which of the following can be measured in order to follow the progress of this reaction? Hey, color, yes. So 3 is a yes. pH, yes, because we got the acid here. Pressure, nope. So it's B, because there are no gas. Okay, consider the following statements and choose the best answer. Okay, I need to draw this out. So, this thing, H, CH, and then C, 1, 2, 3, and then C2, yep, okay. This can exhibit optical activity, yes, because there's a chiral carbon here. So, this one's true. 1 chiral center. Wait, does it have another one? I don't think it has another one. No, it just has 1. So yeah, A. And there we go, boys. We have finished this multiple choice question. Now we have to immediately move on to the long questions. So let's move this away. All right. Oh my gosh, I have no storage space. Amazing. I will have to stop for a while and then, you know, put my videos, yeah. Anyways, oh look, the table below shows some. Okay, so how many questions do we have in here? 15, and the last one is a fucking essay. Great, love this. Protium and deuterium are isotopes because they have same number. Yeah, they have the same number of protons, but different. Is this the first time you see my handwriting? I don't know. Different number of neutrons. Boom. I am 100% sure this is the right way to answer. Deuterium can be represented by D. It can react with oxygen. Okay. Drawing question. Nice. So H2O. So O is they have 6, right? So 1, 2, 3, 4, 5, 6. Yes, they have 6 electrons. And then one here, it's D. Boom! A small piece of sodium metal is placed into liquid water at room conditions. See 2 observations. Not gas bubbles. It's a very vigorous reaction, first of all. Sodium burns, I guess? Burns in a golden yellow flame. And dissolve. Yeah, probably it. And the equation should be sodium plus... do I have to write D2O? Is this really necessary? Okay. D2 will be released, and then the is a NaOH, NaOD. Oh shit. Shoot. 2. Now there is okay, so 2. Okay, I think this works. Next question. Sodium chloride crystal has a giant ionic structure. The diagram below shows a part of the structure of sodium chloride crystal with some ions missing. Why are they missing? This is so dumb. Okay, I'm gonna draw with this. So it's sort of like alternating pattern. This is such a dumb question. Okay, from the experiment, it was found that there are 4 sodium ions and 4 chloride ions in a cube of sodium chloride crystal of volume. Okay, what? Express the total mass of... Oh my goodness. So a volume... So, oh my god. There is, wow, this is actually tough. So, I guess this thing over 4 times 23 plus 4 times 35.5, because like assuming that centimeters cube is the same as grams, and then we got this, yay, and the total mass is this thing times L or Na, I guess. Hence calculate. Oh my god. Given that 1 centimeter cube of sodium chloride weighs, okay. I need to calculate it. I know it's 6.02 times 10 to the power of 23. But okay, if you will. Okay. So 2.17 over 23 plus NaCl molecular mass, formula mass. This thing equals to the number of moles of... Oh my god. This is so confusing. Oh my god. I don't think... Wait, no, what the hell? You know what, since this is so confusing, I am not going to spend more time on this, so I'm gonna stick with this. I tested it. It's obviously not a it's obviously not 6.02 times 10 to the power of 23, but yeah, whatever. It's whatever. I will go back if I have more time. Question 3. An experiment was carried out as shown below. suggest what the orange organic solution may be. Of course, that is acidified potassium dichromate. With the help of chemical, okay, it needs a chemical equation, a full chemical equation, not a half equation, a full chemical equation. All right. This is weird. Shouldn't it react to permanganate instead of, I'm not even going to question. All right, plus 7 H2O. Okay. Yep. 14 hydrogen ions, and then I believe this is a 6. Yep. Out. But here's the thing. The gas got oxidized, which means that originally it was oh my god. Okay, I don't want to write the whole thing, okay, but I think we kind of have to. So C4H8 became C4H C4HOH. So oh my god. No, oh my god. C4H10O2. Yes, because 2 more alcohol groups. Man, this is tougher than I thought. Oh my god, this is tougher than I thought. And then in here we will have 2 H2Os. And because now we have 2 extra hydrogen ions here, so it's going to be this side. And then we're going to give 2 electrons here, I think. And then we need to put these two formulas together. Okay, so this thing times 3, this I don't have to. So this thing times 3 is 6, so water 7 here, so 1 water here. Hydrogen ions 3 to 6, 14. 14 minus 6 is 8, so 8 hydrogen ions. All right, 8 hydrogen ions. Now we have dichromate ions, yeah, and then we have 3 but2enes gas. Okay, next we have 2 chromium ions, and then 7, so 1. All right, and then 3 C4H10O2, and then that's it. Yay! All right. If I get this wrong, I'm gonna be so sad. Okay, distilled water with a few drops of phenolphthalein, balloon with gas X. After a period of time, it becomes pink, and then there's no more gas. So the gas is alkaline. Okay, what's the gas, dude? What's the gas? NH3. I don't know. Leave me alone. Gas, water. Because this is the only kind of gas I can think of right now that can be converted into hydroxide ions. Just to explain, gas X is ammonia, as it ionizes in water to give alkaline hydroxide ions to turn phenolphthalein pink. Okay. Question 4. Oh, hey, we are fast. We are fast. Solid potassium hydrogen phthalate can be used to prepare standard solutions. Its structure is shown below. You are provided with 1.12 grams of solid potassium hydrogen carbonate. Describe briefly how a standard solution containing 1.12 grams of potassium hydrogen can be prepared in the laboratory. Dissolve 1.12 grams of... Do I need to write the whole thing? Hydrogen phthalate into a volumetric flask. Yes. Add water until reaches... I'm not even going to care about grammar. Yeah, until it reaches this thing. Graduation mark. And then shake it well. Shake it and stir it. Just shake it. You know, it's fine. Yeah, shake it. Shake it evenly. Calculate the molarity of the standard solution obtained in I. Hey, so this is the number of moles. 1.12 over... Okay, 5.49 times 10 to the power of -3 mole. And then number of moles. Concentration is this thing over this thing. Yeah, boy. 0.0220 m. There we go. Alright, so 45 minutes had passed, and so we have 1 hour and 45 minutes left, but I think I can do that in time. Alright, so we're back here. For question 4b, at room conditions, the pH of a 0.06 molarity of potassium hydrogen based on this information and appropriate calculation, comment whether the negative COOH group in the potassium. Oh wow, this is a complex question, not something that I've seen before. So I think what we need to do is to I guess I guess I need to find the number of... Wait, no, the concentration of hydrogen ions, right? And to do that, I go 10 to the power of -3.3. -3.3, and that is a 5 times 10 to the power of 4 mole, which is of course lower than 0.06 by a margin. I always forget that my phone is flipped. Okay, so because actually I shouldn't actually I should say 5.01. It's a little more convincing. I don't know if this is the right way to do it, but it's my way, so you know what, screw it. I'm gonna answer it like this. It is what it is. If I get it wrong, I get it wrong. Okay. This group is not completely ionized. Please be a new question when I flip this page. Please be a new question. Please be question 5. Please, pretty please. Hell yeah, it is a new question. Okay. The structure of a compound is shown below. Reacting with a reagent under certain conditions, it can give two compounds with the same molecular formula, C5H10Cl2, but different structures. Suggest what the reagent is. Well, sir, the reagent is Cl2. Yeah, Cl2 in an organic solvent. Actually, this is better because you can't really pass gas into this. I mean, you can, but it's dumb. State the conditions needed: sunlight or UV light. Name the type. Substitution. Draw the structure. One of these two compounds. There are two compounds. This is gives two compounds. This is more complicated than I thought. Draw the structure of the other compound? Oh my, wait a second. This is more complicated than I thought. Draw the structure? Okay, so the structure. So HClCl, and then just this. Now, for sure, this is one of the compounds, right? For sure. What's the other one? Maybe it's like one over here, one over there, but then it doesn't matter then. Then there should be many. Then shouldn't there be many different compounds now? This is strange. Yeah, this is strange. I'm not going to lie. This is strange. There is a great chance that I may be wrong, but yeah. Okay, so H. You can't see the H. Well, there's a great chance that I may be wrong, but I can't do anything about it. These two compounds are isomers. State the type of isomerism. Position. Isomerism. That is what's going on. 6. Okay. Draw the three-dimensional structure of a CH2Cl2 molecule. Hey, it's pretty similar. What the frick? H on the top, H in the bottom. This thing, Cl. This thing, Cl. Actually, it should be on this side. It shouldn't be on that side. But if it's on that side, it's fine. But this is better. Explain why CH2Cl2 is a polar molecule while ClCl4 is not. In CCl4, tetrachloride, carbon tetrachloride, tetrachloromethane. The polarities of the polar CCl bonds are cancel out each other due to symmetrical shape. In CH2Cl2, it is asymmetrical, so the polarities did not cancel out each other. Alright. Explain why ClCl4 has a higher boiling point. That is because intermolecular forces increase with molecular size. Since the molecular size of CCl4 is greater than CH2Cl2, more energy is required to overcome the van der Waals forces between CCl4 molecules. Great. Up next, question 7. We have a 7b. Question 7a. Alright, so this to this, because this is positive, right? Okay, it's a porous pot. What is the function of a porous pot? To separate the two electrolytes, but I guess they allow ions to pass through, if that makes sense. Deduce whether the electrons flow through the external from the magnesium electrode to the copper electrode. Yes, because the multimeter reading, or the voltmeter reading, is positive, I guess. I don't know. Actually, yes, even if I don't look at the reading, like, magnesium is more reactive than copper. Yeah, you know what, let me say that. Magnesium is more reactive than copper. We're to have equation for the change that occurs at the cathode. In the cathode, it's reduction. The one getting reduced is copper, but of course copper doesn't get reduced. What actually gets reduced is copper sulfate. So copper ions is reduced to copper metal. Great. Consider another chemical cell as shown below. Alright, now we're going the other way. What the heck? What the heck? Write the equation for the change that occurs at the graphite electrode. So this thing is now receiving electrons. If you receive electrons, you're being reduced. It's a cathode now. So Br2 is reduced to 2 Br bromide ions. State the expected observation at the copper electrode. Well, now the copper is being oxidized. So, the copper, well, there are two things that may happen. I don't think the sulfate will be oxidized, because duh, how do you oxidize sulfate? So the only way to do this is copper electrode. You oxidize copper electrodes. Yeah, I think so. Yeah. No, wait. Can you oxidize? You can't oxidize copper to ions. You also can't oxidize. Okay, this is weird. Copper electrode becomes thinner and thinner. And I guess I can also say that the solution in the porous pot becomes bluer and bluer, but I guess I don't have to say that. Would the multimeter reading become more negative, less negative, or remain unchanged if the solution of bromine and potassium bromide, you can't see what's up, is replaced by a solution of I2 and Ki, iodine, and potassium iodide, while the other conditions remain unchanged? This is a fantastic question. I have no idea. Iodine is not as reactive. So, if it is not as reactive, then the multimeter reading will be lower, I guess. lower, because I guess that's how you explain it. I don't. Okay, let's take a good look at the. Actually, there is already a periodic table right here. Iodine is not as reactive as bromine, so lower because iodine gas is not as reactive, so it is a weaker. It doesn't want to be reduced, so it is a weaker oxidizing agent than bromine. I think that's a good enough reason. All right, question 8. Several trials of an experiment were performed for determining the enthalpy change of neutralization for a reaction. For each trial, a total volume of 100 centimeters cubed of solution was obtained from the mixing specified volumes of HCl and NaOH as shown below in an expanded polystyrene cup. The HCl and NaOH are kept at the same natural temperature before mixing. All right, for each of the blah, 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 it is estimated from the graph that 58 centimeters cubed of NaOH is required for obtaining possible maximum temperature reached in this experiment. Show how this estimation can be done. Okay. Is this okay? I'm gonna do this. Yeah. I'm gonna do this. Yeah. Alright. Yay. And then I'm gonna make another line here like this, I guess. Like this. So it is indeed right here. 58. That is not what 58 looks like. What the frick? 58 should be right here. What, am I doing something wrong? I don't know. I do not know. I'm not doing anything wrong here, because this is the initial temperature. I don't know. Anyways. Calculate the number of moles of NaOH reacted with HCl. Oh, it's actually pretty cool that they already gave us the 58.0 centimeters cube of NaOH is required, so that we don't have to actually look at the graph, because what if we fuck up the graph, All right. Number of moles of NaOH reacted with HCl in A. I guess 58 out of 1,000 times 1. 8 moles reacted. Hence, find the concentration of HCl. So, number of moles of NaOH. And then concentration of HCl. What? This is somewhat complicated than I thought. More complicated than I thought. Oh, so I guess. So do I do this? This is weird. This is really, really weird. But I guess if it makes sense, it makes sense. 1.38 molarity. Yeah, so in this case, the same number of moles of HCl and the same number of moles of NaOH react. I'm gonna stand up. My legs are broken from sitting for so many hours. Given that the initial temperature of the mixture for each trial is 25.5 degrees, okay, calculate the enthalpy change of neutralization of the reaction. Okay, I can do that. Oh, shoot. So 58, say 58 centimeters cubed of NaOH. Oh no, I was right the whole time. This is 60, this is 70, this is 58. I was right the whole time. So the highest temperature rise is actually 33.1-ish. So I'm just gonna assume it's 33.1 degrees Celsius. Okay, so this is the temperature change. M, mass of water. What is the mass of water? 100, I guess. Yeah, I think it's 100. So yeah, 100 grams per cm cube. So it is 100, and then 4.18, and then over the number of moles of I guess this thing. Wait. Number of moles of what? Shoot, number of moles of what? I feel like it's 0. Yeah, duh. Because both NaOH and HCl also reacted with the same number of moles. So the answer is 100 times 418 over 0.058. And then, of course, it's super large, so we need to do this. Actually, turn it to an 8, because we need to round it off. There we go. It is exothermic. Ow. Oh, earthquake. Alright. The one determined above is not the standard enthalpy change of neutralization. RIP. What then is meant by the term... What? The enthalpy change when 1 mole of water is formed under standard conditions. I feel like there's going to be an 8C. I have a bad feeling about this. Oh, nope, never mind. 9. Iron cans used to store food products are commonly coated with a thin layer of tin. Thin layer of tin prevents iron cans from corrosion because there are two principles. These iron cans would corrode easily once they're sort of... Okay, I guess the prime principle is that the tin layer blocks the iron from being exposed to water and air, so it will not rust. These iron cans, nope, because wait, yes. Yes, actually. Yes, oh shit. Because iron is more reactive than tin. Iron acts as a sacrificial metal to lose electrons instead. See, the way I'm answering these questions, I need to hit every keyword as possible, like reactivity, sacrificial metal, electrons. Suggest why galvanization So galvanization with zinc. Zinc ions are poisonous. There is an increasing trend for manufacturers to use cans made entirely of aluminum for storing food products, explaining why aluminium is more resistant to corrosion than iron, although it occupies a higher position than iron in the reactivity series. Aluminium forms a layer of aluminium oxide when oxidized, which protects the aluminium. Okay, I feel like I should do this, then you guys can see better. Name the process: anodization. Other than corrosion resistance, it's just one advantage of it's cheap. Using aluminum, other than corrosion resistance, what is it? What is it? It's lighter? I think it's lighter. Yeah, it's lighter. Essay question. The first essay out of the 2 essays, because I need to do another one later. You are provided with a common laboratory apparatus and relevant chemicals: iron powder, zinc powder, blah blah blah. How zinc sulfate crystal can be obtained from a solid sample of zinc sulfate containing copper 2 sulfate as impurity. Not all chemicals must be used. Okay. Copper 2 sulfate. We need to both of these things are soluble, right? If I use aqueous ammonia on these two, they will both redissolve. So it's not gonna work. Iron powder. Iron is more. Oh, I know. Dissolve the sample in distilled water first, right? Mix it well. Add iron powder. Oh, I know, it's a puzzle. I don't add aqueous ammonia to the zinc and the copper because they both redissolve. First, I displace the copper 2 with iron, and then I add ammonia. And iron plus ammonia becomes a white precipitation, has a white precipitate. So I filter it, and then we got the zinc sulfate, and then we crystallize it. That's exactly what I do. Oh boy. Add iron powder into the solution. The iron displaces the copper 2 ions. Okay. Now we have just copper metal, right? And do we have to filter it, or do we just... Nah, we'll filter it later. Okay, now add excess aqueous ammonia. Precipitate is formed. So filter the solution. And then you heat up the filtrate and let it cool to room temperature. There we go. collect these zinc sulfate crystals, wash it with cold water, and dry it. Boom! Cracked the puzzle. Question 11. 2 trials of an experiment were performed using the setup below to study the reaction between nitric acid and calcium carbonate. A gas was formed in the reaction. Okay. Yeah, I can do this. What? HNO3. Alright, and so it forms calcium nitrate, which is actually soluble, and then H2O, which is, and then carbon dioxide. We need to make it the 2, and then, yes, and then okay, yeah, it's perfect. Perfection. Alright. Now we got this, trial 1. Trial 2. Okay, so I guess for trial 2, we have more number of moles of nitric acid, I guess. Calculate the average rate of formation of the gas from the 2nd minute to 12th minute for trial 2. What? Formation of the gas? Carbon dioxide? Oh. Okay, so at 2 it is, what the 83 minus 82.5, 0.5. So each square is 0.5. So 0.5 times 4 and 83 minus 2. What? No. Whoa. Hold on. Oh, duh. 83 minus 82.5 over 10. So each small square is 0.05, and then times 4, and then 83 minus that. We got an 82.8. So 82.8 minus the 12 minute. At the 12 minute, it's right here. It's 82. It's 82 over 6 minutes. To be fair, it's not 6 minutes. To be fair, it's 11 minutes, but the right answer should be 10 because logic. So 0.8 over 10, 0.08. I think grams per minute. Explain one difference in the shape of the curves. Trial 2 is steeper than trial 1. What? Okay, trial 2 is steeper than trial 1. So less gas is released now? What the heck? Okay. Or no, more gas is released. This is the mass measured. So it is steeper than trial 1 because the rate, not really, the number of moles of nitric acid is reacted with calcium carbonate. So more products are formed. So just how the effective surface area of solid reactants. Okay, do the experiment with powdered calcium carbonate and lumps. under same mass. Oh wait, it's only 1 mark. Yeah, under the same mass. Measure the rate of gas formation. Alright, we got this. Question 11. No, question 12 already. Damn. We are fast. Alright, consider an equilibrium mixture of the following chemical reaction. Write an expression for the reaction Kc equals to, okay, V3 plus AQ, okay, this is annoying. AQ. At a certain temperature, the equilibrium constant Kc of the reaction is less the equilibrium mixture prepared by mixing 20 this thing with this thing. Okay, let's make a table. ICE. Okay, so what the fuck? Do I need to find the number of moles of this thing first and then make it over 30? Okay, 0.02. That is mole per dm cube. And then this is 1. Also 0.01. And then 0 minus 6 plus x. So now x over 0.02 minus x 0. Minus x equals to this thing. Okay, let x be the concentration of the equilibrium concentration. Okay, maths time, yay. Oh, actually, you know what I can do? I can actually do this. 1.08 times 10 to the power 3. Oh god, you know what? I'm not gonna do that thing. Actually I can do that thing, but I don't want to do that thing because it's so annoying. But I kind of have to do that. Okay, you know what? I'm gonna do that thing. I'm gonna do that thing where I turn this into this, and then okay, 0.02. I know it's dumb. I'm calculating this, but it's important because I don't want to mess up. And then x, okay, now quadratic formula. 1 minus this for safety measures, plus 2 negative 4. So x is either 0.0217 or 291. This is rejected. Yeah, because no way, no way. So the concentration is this thing. There we go. It is known that the equilibrium constant increases when temperature increases.